I want to give a quick tutorial on reindexing series and also show you an example where reindexing the series given makes the math problem much easier. So let's suppose your only task was this: reindex this series so that the series starts at index 0. So notice that this isn't that difficult of a series except for this one little exotic detail: k starts at 2. And I really want it to look like this. I want it to start at 0 at the bottom and go to infinity. But the problem is that this expression is going to change, and I have no idea what it's going to be. So I'm going to start by writing out the first terms of the series in long form. It just helps my brain to do that. I substitute k equals 2 in here, then k equals 3, then k equals 4, and then k equals 5. On top of that, I'm going to help myself by writing down which index goes with which term. This is the second term, the k equals 3 term, the k equals 4 term, the k equals 5. Okay, now I want the series to start at index 0, which means I'm going to introduce a new letter and just decide that 1 over 4 is going to be the index 0 term. And so this is going to be the I equals 1 term, I equals 2, I equals 3. Can you tell what the conversion between k and I is going to be? K is always 2 units higher than I, right? So it's really easy once you're looking at it this way to find this equation, that I is equal to k minus 2, or k is equal to I plus 2. It goes either way. Now that you've got all this information, here's what you're going to do. You're going to say that here's my original series, and we're going to change out this thing, and the k. We're going to substitute all three of those things. And so the k equals 2 becomes I equals 0, because when k is 2, I is 0. Infinity, as k goes infinitely high, I goes infinitely high. I is only 2 units behind, so it also gets infinitely large, so that doesn't change. And the substitution is just straight up algebra. I'm going to take away that letter k and replace it with I plus 2. I substitute this guy a little bit, I simplify this guy a little bit, and what I get is the series from 0 to infinity of 1 over 3k plus 4. Now, what's going on here, in case you're curious, is just me changing the letter out. Like, you can choose to switch the index, or you can choose to recycle the index k if you want. Like, this is literally supposed to represent a different k from this guy. That's pretty standard in math, and it's no big deal. So here's a problem. Compute the sum, like literally find this sum. The sum from k equals 2 to infinity of 5 times 1/3 to the k power. It's a geometric series, right? But the problem is that the answer is not 5 over 1 minus 1 over 3. That formula only holds when the series starts at k equals 0. So that's where reindexing can really help us. If we can get this thing written in a better way, we're going to be able to use this really cute formula and get done with this problem. So once again, here is my series, and I'm going to make this substitution. Instead of writing out long form, I'm going to try to do it just straight up algebraically. I is equal to k minus 2, and so that means that I starts at 0, and it goes to infinity. I get 5 times 1 over 3 to the I plus 2, right? Because k is equal to I plus 2. Well, once I simplify that out a little bit, right, because this 1/3 to the I plus 2 splits up this way, and that means that this junk, 5 times 1/3 squared, that's my a, and 1/3 is my r. So the sum is actually 5/9 over 1 minus 1/3, which simplifies to 5 over 6.